We warmly welcome all of you all to our grade 9 science seminar session. So this is conducted by Rihan Rahim. So I think most of you all know about me. We have met many times. This is our third grade 9 science seminar session. So you know our online classes, we have been doing that for more than now almost 2 years online classes. And last year was our one of the main online batch, and this is our second year of online batch. So for now, we have given more than 20 free seminars for each and every grade, and this is our third free seminar for grade 9. I hope most of you all have come to our classes earlier and know about our pattern of teaching and all those things. Okay, then without any further introduction or any other motivation or anything, because normally I give some counseling, all those things, but now I think it is high time that I don't need to give motivation, because y'all are itself self-motivated, because slowly, little by little, you're moving towards your grade 10, that is O-level life. Okay, at the end, I will tell you about the O-level life and the foundation, that is grade 9. All those things will be told at last. So now we will go to the session. So today, most of the time, I used to select biology-related seminars, because biology-related seminars, it is easy, because I can explain with all the pictures and animations and all those things, I can explain. But today, many of the requests from the students was physics lesson. Okay, because in school, the problem is they are not differentiating between biology, chemistry, and physics. Okay, they are not differentiating between biology, chemistry, and physics. I hope you all can hear me clearly and see the screen.
Yeah.
Yes, sir.
Yes, sir. Yes, sir.
Clear.
Okay, Hari, thank you. Okay, so you know, and many requested this physics part, because in school they are not teaching separately bio-related lessons, chemistry-related lessons, physics-related lessons for grade 9. They are teaching everything like a acharu. Okay, but when I teach my students, I clearly tell, even for grade 6, grade 7, grade 8 students, I clearly tell them, students, today y'all are going to learn physics lesson. Today y'all are going to learn chemistry lesson. Today y'all are going to learn bio lesson. Then only it is easy for the students to change their pattern, because bio you have to study like a bio person. Chemistry you have to study like a chemistry person. Physics you have to study like a physics person. If you try to mix, if you try to memorize everything, then it will be a utter failure. Okay, so that's why now itself I am telling the students, before starting the unit 14 is related to reflection and refraction of waves. So it is mainly related to a physics lesson. So when learning a physics lesson, it's not like the bio lesson. Okay, like a baba, you can't listen and wait. You have to write something. You have to mark the points. You have to draw the graphs. Like that, you have to be very active while doing a physics lesson. If it's a bio lesson, you can continuously listen and wait, because bio is understanding, physics is application. Okay, you have to draw the diagrams. Today, I will draw one of the hardest diagram in your syllabus. I will make it very easy. I will show you some short forms to draw it. I want you all to draw that diagram also. Okay, so students, today we have a long day. Okay, we have a long session. Okay, this is not an easy session, very hard session. So I took this as a challenge, because any bio lesson, we can put the pictures and explain everything. But physics lesson, I have to draw it. I have to show it in such a way that you understand completely. So I hope all of y'all are ready for this journey which we are going to go today. Are you all ready to embark on this journey, a physics journey?
Yes, sir.
Someone, I think someone wants to go out. You can unmute and speak now if you are really want to go out. Okay, so then we'll go to the first part. Okay, we'll go to the first part. Many types of waves are available in the world. If you take the world, we have many types of waves. Out of that waves, the waves related to our syllabus, grade 9. Now, you don't know, but the grade 9 syllabus is connected. Okay, now I will show the connection. The most two important waves today which we are going to study is about the light waves and the sound wave. So today we will finish one of the major part of light wave. We can't finish the full chapter. Full chapter is almost around 8-hour unit. Okay, this is a 8-hour chapter. That means 3 to 4 classes needed to cover this. Okay, so I will cover 4 hours lesson within this 2 hour, because this is a seminar. Okay, you can be listening to this. Don't need to write everything. Okay, don't need to write everything. I will send the PDF after the seminar in our free groups. If I will send all those notes, all those things. So don't worry. But when we are drawing the diagrams, you have to draw the diagram. So what is the connection between these light waves and sound waves? Can you all remember our first seminar? No, second seminar. It was related to the eye, because you know in your grade 9, second unit is related to eye and ear. So eye detects what type of light, what type of energy? Light energy. What type of energy is detected by the ear? Sound energy. So light energy comes by light waves, sound energy comes by sound waves. So can you understand the connection between the eye lesson and the light lesson, the ear and the sound? Okay, so don't think just you all are learning. There is a comparison, there is a connection between a lot of things in your syllabus. Okay, anyways, no problem. So today we'll move to the light waves. So you can see that a bulb is being lit. Why? Okay, light is one of the most important form of energy in the world. We all know that. Just imagine suddenly if the current goes now in my home, what will happen? Everything will become dark. My Wi-Fi will get off, my light will get off. If my camera is on, what can you see? You can see a full dark image. Why is that? All what you see is because of light. Okay, if it is daytime, sunlight is there. But if it is night time, sunlight is not there. Therefore, artificial lights or candles are needed. So the light is one of the most important form of energy in the world. In grade 6 also you have studied, in grade 7 also you have studied, in grade 8 also you have studied certain things about light. Okay, there are many types of light, and how the light is traveling through the transparent object, how it's traveling through the translucent object, and how it's going to travel through the opaque object. Like that you have studied. But now today you are going to learn a real physics part, where we are going to talk about the reflection, how the light rays come and bounce and go out. Okay, that is known as reflection. One by one we will study, so don't get upset. Some students in school, because of the corona problem and because of the teacher strike, what is happening? They are not learning anything. Just raise the hand and show how many schools they are striking, and you all are not having any classes in school. Just raise the hand. More than 150 students, they are raising the hand. That means the schools, government schools, more than 200. Oh my God. Okay, so it's a very sad situation. The teachers are not teaching, and the students still, some schools, they have not completed the first term lesson. So what are they going to do for second term, third term? I don't know. It's a very sad situation. So I am trying my maximum to give the free seminars, to cover whatever possible ones. The ones who are coming to my theory classes, they are covering everything on time, but every class I can't give free, no, because I'm under one institute. So therefore, whatever possible, once a month I will give a free class, but all the others, you can come to our normal theory classes or go to some other classes and learn your theory properly. Okay, then we'll move to this part. Whenever you want to see an object, whenever you want to see anything, your laptop, your books, your pencil, your home wall, your phone screen, anything, there should be two things. Do you know what is the two essential things needed to observe something? Very common thing.
Light.
Light and vision.
The light and source of light.
Okay, many said correct answer. Light is needed. Okay, let's imagine like this. There is a blind person. Can he see? How much ever light you are putting, the most powerful light in front of him, can he see anything? No. Let's say you have a very good eye vision, but no light, total dark, then also you can't see. So from this you can understand there are two things needed to see something or anything. What is the two things? One is light, other one is sight. Light and sight. Okay, so just write only these two names. Light and sight are needed to observe or see something clearly. So from this image, okay, from this image, you can see that there are light and sight. Now, normally in grade 6 and 7, you have studied all the objects according to their light. It can be considered as luminous object, non-luminous object. I hope all of you all know that. No, now small, even the grade 7s, my students, if I ask what is luminous, non-luminous, they will tell. Luminous object, they can emit their own light. So therefore, if you see any luminous object at any time, what will happen? You can see that directly. The moon, normally moon is borrowed light, no? The sun, the stars, the light, the phone screen, the laptop screen, the candles, the bulb, directly you can see that without any problem because they are emitting direct light. Then what about all the other things in the world? Your book, your pen, your wall, your mother, your father, your friend's face, all these objects, how they are not emitting light, no? When you look at your friend's object, like a bulb, from his face, light is coming. No. Then how can you see your friend's face? That is because the light from the room or the sun, it falls on your friend's face and comes to your eye. That means not only the light which is coming from the bulb, there is some light which is coming and falling on the object and reflecting back. That light also you can see. Okay, because of that only you can see this apple. Can you understand? So light and sight both are needed. Luminous object directly we can see. Non-luminous object, the reflected light can be seen. I hope this is clear. I am explaining very slowly because now today is a seminar. No, there are fast learners and slow learners. Okay, because I'm a psychology counselor. I know in the world there is no weak student, there is no intelligent students. All are intelligent. But the problem is there are some students, they catch up very quickly. They catch up. Some students catch up late. Okay, you may be a late. The person who understands things late, but it doesn't mean that you're not intelligent. Okay, some people, they will tell you, no, some students are very intelligent, you all are not intelligent. Sometimes even the school teachers tell, no, the one who comes first, second, third, fourth, they are intelligent. 5, 6, 7, 8, 9, 10, 11, 12, 30, 40, 50, 60, they are not intelligent. No. They also have a brain, they also can use the brain, but the process is slow because of that. Okay, today in the seminar, a lot of students are there. Therefore, I am going slowly so that everyone can understand. I will challenge and tell you, if you can't understand my explanation, you will never ever understand anyone else's explanation. Because in Colombo, I have got a reputation that I am the science teacher who is explaining the things in the best possible manner. Okay, so I hope you can understand with the presentations, my explanation, everything is clear. Okay, now we'll go to the next thing. Light is composed of very tiny light rays which travel in straight lines. So you can see one thing, one light is called light ray. Then when light is coming from your bulb or from the sun, it comes in bundles and bundles of light. So totally we call it one source of light. But in that source of light, or in the light, there are tiny light rays. When the light rays are going, it will travel in straight line. So if you look at a real light ray, this is a laser beam. All of you all have seen laser light, no? How many of you all have not seen the laser light? Just raise the hand. Laser light. How many of you all have not seen laser light? Oh, many have not seen laser light. Okay. Because when we were small and all, we used to play with the laser light. It goes for a very long distance. So this is one laser light. Okay, one laser light, it's going in a straight line. Normally it doesn't go crooked. When it knocks to a surface, it may reflect back. When it knocks to some surface, it may change its direction, but it will always travel in straight line. So light rays don't travel in crooked lines. It don't travel in circles. It always travel in straight line. So some of the MCQs in the past paper questions, okay, my students, they will be doing the Colombo papers. Normally I am based on Colombo. My institute is in Dehiwala. I think all of you all know Dehiwala, no? In Sri Lanka, everyone knows Dehiwala. What is the special about Dehiwala?
Zoo.
Zoo, no? Very good. So everyone has come to the zoo, no? Everyone knows Dehiwala. So my institute is based in Dehiwala. So I get all the Colombo papers. So most of my like in grade 10 and 11, we do the Colombo related papers. So in the Colombo related papers, they are asking some very like tough questions. Okay, one common question is these MCQs related to the pathway of light rays. Okay, so they will give many pictures and they will ask you which pathway is correct. Always you have to check whether the light ray is traveling in straight lines. Okay, if it is traveling in straight line, it is an exact light ray. Are you all clear with that? Okay, because today it's a seminar and there are a lot of people, there are unknown people, there are people who are not related to science, just some fellows. Those fellows also have come, I know, because from the other institutes they are coming to check my teaching and techniques. Okay, so they will try to disturb, so that's why I have unmuted, I have muted it. In my normal theory classes, we unmute, our students speak, we exchange a lot of things, lot of ideas we exchange, but today we don't have that opportunity because too much of students. So no problem, I hope you will understand. If I ask you a question, if you don't have the option to unmute, no problem, at home louder tell your answer. The more you speak, the more you will understand. There is a psychology point. If you want to study something, first it has to go to your mouth, then only it will go to your mind. What is the meaning it has to go to your mouth? You have to put the book inside the mouth and eat? No. First, you have to repeat those words again and again. Okay, some new words will come, especially in bio. You have to repeat those words again and again. Then only, first it will go to the mouth, then only your mind will understand. Okay, so if someone you feel like you are how much ever you're studying, you're not understanding that, study louder, read louder and try to study. You try the technique and tell me how the improvement. Okay, so you know about the straight line. Then we'll go to the next one. So now the prayers are being said here, the azan is said. So for 2 minutes, I will give a break. Okay, so don't leave, we will continue. Don't leave, we will continue. 2 minutes break. Okay, students, then we will continue because of the azan prayers. I gave 2 minutes break. Okay. Light travels through a vacuum or a transparent medium in straight lines. Okay, always remember light rays, it is special. 1 minute. Okay, now clear, no? Yeah, light ray is special. It can travel even through vacuum. What is vacuum? Some students don't know vacuum. Even in grade 6, 7, 8, you all are studying. No, what is vacuum? Vacuum is a place where there is no gas, no liquid, no solid, nothing. Okay, one best example for vacuum is outer space. In grade 8, you all have studied, no? Our atmosphere has stratosphere, troposphere, thermosphere, exosphere, like that. Out of our atmosphere, it's totally vacuum. No air. Can you go out and survive? No. You have to have oxygen. You will be floating because no air, nothing, no gravity also in that. Okay, so even in the vacuum, the light can travel. But sound can't travel through vacuum. Okay, if you want, please note it. Sound cannot travel through vacuum, but light can travel through vacuum. It's an extra point, MCQ question. Okay, it's a type of MCQ question. So you write and keep. Light can travel in vacuum. Sound can't travel in vacuum. There is an experiment also in grade 10. We will do that. Okay. And in transparent medium also, this light can travel in straight lines. Okay. Then when they are traveling in the straight line, they can do one thing. They can reflect when strike on a reflecting surface, maybe a shiny surface. The best example for reflecting surface is a mirror. So whenever you put a light ray to a mirror, exactly it will get reflected. Can you see? This is a laser light beam. It is a very, very powerful laser light beam. They have done an experiment and they are putting it on a mirror and it is directly coming out of the mirror. Okay, it is being reflected. Okay, some students don't know this word. Reflected. Reflection is reflected. Later you will learn refraction. Okay, not today because that's the next part of light ray. Refraction is different. Reflection is different. The mirror is the best example. So this is the definition of reflection of light. Normally they will ask you in the structured essay question, what is the definition of reflection of light? Then what should you write? Bouncing back of light rays into the same medium when it strikes on a surface is known as reflection of light. Bouncing back, the light ray which was traveling in one medium, when it touches the shiny surface, it will jump back. Like you have a tennis ball. You're aiming at a wall and throwing the tennis ball. What will happen? The tennis ball will go, knock on the wall and bounce back. Like that, light rays also traveling very fast. Light rays travel very fast and they knock on the wall, knock on the mirror and they bounce back. That is known as reflection. So you can see from this, from a torch, the light is coming and falling on the mirror or shiny surface and it is reflecting, bouncing back to a human eye. So therefore we can see that light. Okay, because of this reflection only, we can see our image in the mirror. Every day we are using the mirror to see the image. Okay, so can you see? This is the real cat and this is the image of the cat. Okay, so we will be learning today how is the image forming from a plane mirror, all those things, very tough lessons. I hope now you have a real idea, because when they were doing this in school, I got the feedback from many students. They were saying, so this is very boring, waves is very boring, simple machine is very boring, can't understand. But now I think you can understand this is interesting. If someone teaches you in a proper way, it is very, very interesting. So you can understand, because of the reflection ability of the light only, we can see our face in the mirror. We can see other things in the mirror. Why? Because of the reflection ability of the light. If light can't reflect, what will happen? You can't see your face in the image. You won't be able to see other people clearly because no reflection. But God has created reflection. Therefore, all the objects are visible through the mirror and to our direct naked eye. Hari. Then reflection of light ray by a plane mirror. So whenever you put a torch, the torch light will go. Now we can't see this light, but if you keep some smoke, okay, if you put some smoke, you will be able to see how this light ray is going, knocking and returning back. So now you all are grade 9s. No, you all can't just leave like this. You should be able to draw the diagram. Okay, you should be able to draw the diagram. There is something known as the angle of incident, angle of reflection. Okay, so now I will show you how to draw this one. Now, before going to the drawing, our book, they are giving a lot of activity. These are very, very, very small things, but they are trying to make it a very big thing. After doing the activity, the students don't know what is the output. Okay, so don't worry, just read the activity. I will explain the activity in the whiteboard. Okay, so you need a plane mirror, a sheet of white paper, an electric torch or a laser light, a pair of scissors, a ruler, protractor, and a pencil. Place the sheet of white paper on the table. Place the mirror perpendicular to the paper using a stand. In school, maybe they are doing this experiment, but I will explain in the board clearly. You won't get any doubts. Draw the mirror lines on the paper. Direct a narrow inclined beam of light, okay, along the paper on the mirror using the electrical torch or the laser light. Observe how the beam of light reflects from the mirror. Trace the incident ray, reflected ray on the paper using the pencil. Remove the light, remove the mirror and complete the ray diagram using a ruler. Construct the normal line to the plane of the mirror at the point of incidence. Measure the angle at either sides. Okay, now you all don't know anything. What is this reflected ray? What is the incident ray? What is the point of incident? What is the normal? You don't know anything, but they are giving in the activity. So someone should do that activity, no? So some students are there, they try to learn without going to school or without going to any classes. They are trying to read the book and study. Maybe other subjects you can read the book and understand, but science, some expert, the one who knows real science should explain to you, then only you will be able to understand clearly. Okay, then we will go to the camera. Give me 1 minute. Okay, we will go to the camera. I have 2 cameras. I will on both the cameras. So you can use any camera which is more clear to you. Okay, the one which is more clear to you, you can use that for you. Okay. Can you all see the whiteboard clearly?
Yes, sir.
Okay, so 2 cameras are there. The ones who are saying blurred, please go to a place where there is more connection. I am in a place where there is highest connection in Colombo. Okay, so you will be able to see clearly. If you can't see, you change the screen or a little bit go out and go to a place where there is more and more connection. Okay, now what are they telling us? Okay, they are telling us. Okay, so many students, they wanted to see me. So I am only your science sir. Most of you all know me because you have come to all my old seminars. So hi to everyone. Okay, then today, because we have a very, very important session, we'll go to the session without any further talk and all. Then in that experiment, they are telling you to take a piece of paper. Okay, we'll take a piece of paper. This is only our paper. Okay, see nicely. Yeah? This is only our paper. Then they are telling like this to take a mirror and keep the mirror like this. Okay, so this is the mirror. You can see the mirror. They are telling to keep like this. So we are keeping the mirror like this, but we are drawing only the mirror line. Okay, we are drawing the mirror line and think that you have fixed a mirror. Think that you have fixed a mirror. Then to that mirror, what are you doing? To that mirror, you're sending a light ray from a torch or from a laser light. Then what will happen? The light will go like this, knock and return back. It will go and knock and return back. So what is this line? This is the mirror line. Okay, the back part of the mirror we color like this. Okay, so this surface is the reflecting surface. This is the mercury surface. We call it mercury surface because to make a mirror, you need to apply mercury to the opposite side. Now you all are okay, no? So you kept a mirror like this, you kept a light like this, the light is going, knocking and turning. Now you have to take a pencil or a pen or whatever, and they are telling to trace it. So you have to trace this. You have to trace this line. The line which is going from the torch to the mirror. This line is given a special name, incident ray. Incident ray. Okay, incident ray. Okay, please follow this. If you follow this, because at the end it will be a completed diagram. You won't know what is this, what is that. So now itself, listen properly. This is the incident ray. We are showing the arrow how it is going. Then from there it is knocking and returning back. That also you have to keep a ruler and you have to trace that line. We are tracing that line. Okay. We are tracing that line. That line is known as the reflected ray. Reflected ray. So we have two rays, incident ray, reflected ray. Then what do? And you have to put the arrow. You have to put the arrow. You have to put the arrow. You have to take a protractor and keep perpendicular to this. You know the protractor, right? You have to keep the protractor, this point where it is bouncing. Now you are sending a tennis ball. The tennis ball is knocking and bouncing and coming. So that bouncing point, okay, here the light ray is bouncing. That bouncing point is known as point of incidence. That bouncing point is known as point of incidence. Can you all see that green color one clearly? Or I'll write in red color. Okay, point of incidence. This point. Point of incidence. So now you all know three things. This is the incident ray, reflected ray, and the point of incidence. To this point of incidence, you draw a perpendicular line. I think you all know in maths what is perpendicular. If you have one line like this, if you want to draw a perpendicular line, you have to draw like this. Okay. So I am going to draw a perpendicular line from the point of incidence. So I will keep my ruler. Where is my ruler? Okay, I will keep it here and draw . Okay, I hope you all can hear me clearly.
Yes.
Yes, sir.
Okay.
Yes, sir.
Hurry. Okay. Then this is known as the normal. Okay, this is known as the normal. Then now you know four things: incident ray, reflected ray, point of incidence, and the normal. Okay. The angle. You all know angles, right? In maths, you all have studied. If there is a triangle like this, you can find the angle. Maybe 30 degrees, 60 degrees. Here, you don't need to find it. Here, what is the name given to the angle between incident ray and reflected ray? This angle is known as angle of incidence. We put a I. What is the meaning of that I? Angle of incidence. Or angle of incident, no problem. Then between the normal and the reflected ray, there is another angle. We call it R. So now you all tell me what is that angle?
Angle of
Angle of reflection.
The level of reflection. Angle of reflection.
Yes.
Like that.
If incidence side is angle of incidence, reflected side is angle of reflection. Angle of reflection. So I will put the symbol here, R, that is known as angle of reflection. So this is only a real ray diagram related to the reflection of light. I hope it is 100% clear, because some students, they look at the picture in schools nowadays. What are they doing? Because online classes, they are printing all the notes and sending. After printing, the full thing is there. The students can't understand which one is incident, which one is reflected. So that's why I told you, please follow the class properly. Then only you'll be able to understand. From the light source, light ray is going. We are tracing that with our pencil. That is incident ray. Then the reflected ray, we are tracing with our pencil. That is the reflected ray. And the point, the bouncing point, the ball is going, bouncing point, that is known as the point of incident. From the point of incident, perpendicular, we draw a line. That line is known as normal line. Then the normal line is dividing like a cake, like a pizza. It's dividing two parts. One is the incident side, the other one is reflected side. The incident side is known as the incident angle, this angle, and this angle to this side, the reflected side, it is known as the angle of reflection. I hope it is 100% clear. Quickly draw this. This is the experiment. How many times, even if you read the experiment or the activity, you won't understand unless someone explains this. I hope this is the best explanation you have got. If there is any doubts, you can type and send, because if I tell to unmute, many messages will, everyone will talk. I won't be able to understand. Try to draw this. I will give you 2 minutes. Draw this completely. And after that, if you have doubts, send me through a text message in chats. Okay, students, we will continue. Sorry, I think because when I gave the chat open, I told you, no, there are some unwanted people because they come for all the free seminars and they try to whole court now. We'll put some people out and come. Okay, sorry for the disturbance. Okay, I'm really sorry because some unwanted people were coming and chatting because I had put it open from the institute. They have put to everyone. Okay, sorry for the inconvenience. No problem. Those are the people who don't have any other works. They are coming to other people's seminar. No problem. If anyone wants, if there's any problem, I will give my phone. If you're a real people, you can call me. Okay, you can call me and we'll see who. Okay, then we will continue. Okay, so I hope you all are okay, 100% okay with the ray diagrams for reflection with plane mirror. Okay, so then the next one, the ray that falls on the mirror is called the incident ray. Okay, the incident ray. So now you have drawn that picture. So okay, you have drawn that picture. Now look at the picture and try to understand. Okay, now look at the picture which you have drawn. Okay, so if I tell you to do a work, if you do that work only, it will be interesting and it will be worth. Okay, so when you look at that, the ray that falls on the mirror, which is coming to the mirror, look at the arrowhead. It is known as the incident ray. Then the second one, the point where the incident ray contacts with the mirror is the point of incidence. I told you that bouncing point is the point of incidence. And from the bouncing point, the ray comes out. Okay, that is known as the reflecting ray. Okay, the ray that reflects away from the mirror is known as the reflecting ray. So incident ray, point of incidence, and the reflecting ray. Now you all are 100% clear. Now the gaps, the angle between the incident, the other one, the perpendicular line drawn to the mirror at the point of incidence is known as the normal or the normal line. I told you normal line. It is the normal line. It is perpendicular to the mirror, always perpendicular to the mirror. Then now the angles between the incident ray and the normal, like a piece of pizza, I told you that is known as the angle of incidence. And the other part, the angle between the reflected ray and the normal, that pizza, think like two pizza parts. The other pizza part is known as the angle of reflection. I hope it is 100% clear. Now this same experiment in school, they will tell you to do with a pin. Okay, they will give you 4 pins and they will tell you to do this. That also I will try to explain. Okay, it's not a very big thing. If you do that in school, you will understand more clearly. But now you don't have school because of the corona. So we'll see what's happening. Okay, we'll see what's happening. Don't know when the school will start. So without putting a light ray, Okay, without, now here you have to have a light source. No, you have to have a torch, or you have to have a laser light. You have to have a torch or a laser light. If you don't have a torch or laser light, still you can do this experiment. How to do that? Again, I will erase this. You should have a white paper. These are very, very simple things, but in school they are not giving the proper explanation. Therefore, the students can't understand. Okay, so don't worry. My main specialty is explanation. So if you come to my classes, 100% explanation will be there. Notes also I will give. Okay, I have very beautiful all this PowerPoint and all. I don't think whether other teachers are doing that, but in my classes I will be giving all the PowerPoint PDF. But the most important thing is the explanation. So here, now what are you doing? You're keeping the mirror. Okay, I told you this is the mirror. You're keeping the mirror like this, facing downwards. These are reflecting surface. And then you keep okay, give me 1 minute. My camera got stuck. Okay, now I hope it's okay. Okay, now I hope it's okay. Hari, so you keep two pins like this. One pin like this, another pin like this. Or you can draw a line like this. Okay, first you draw a line and then put two pins. One pin here, the other pin here. In school, they will do this experiment, then nicely concentrate. Then you go to the other side. Now you are this side now. You put the pin from this side and go to the other side and look at the mirror. Look at the mirror like this. Then you can see the pins on the other side. Reflection you can see no. Then while looking at that, you put two pins here. One pin here and straight line you put another pin. Then what will you do? You will connect these pins. You will connect then these pins. Okay, you will connect these pins. Then also you will get the incident ray and the reflected ray. First, how did you get? By putting the torch light. Light went, light came. But now how are you doing? By drawing a line and keeping the pin and looking at the reflection of the pin, you can see the reflection of the pin along this line. So you are drawing this line. So this line is known as incident ray. This line is known as the reflected ray. Again, at the point of incidence, you can draw the normal and the angle between this incident ray and the normal angle of incidence, the angle between the normal and the reflected ray, angle of reflection. Okay, the same theory in two experiments. Okay, two experiments for the same theory. I hope it is. Okay, I hope it is 100% clear now. Okay, then we'll go to the next part. So that is to how to do that experiment with the pins. Now don't need to draw again. The same thing, without drawing the torch light, you can put the two pins and do this experiment. The same results you will get. Okay, so in school, when the school starts, tell your teacher to do this. I don't know whether they have the equipments to do it, but they will try. Some schools they will do and show. Then you will be able to practically do this. But now I think you understood the method. Okay, you understood the method. So because of that, then finally in two methods, you are getting this diagram. From this diagram, we are coming to a conclusion. Okay, that is known as laws of reflection. You have to memorize these laws of reflection. You have to memorize. So today read again and again, then only you will be able to understand when light is reflecting. Okay, when a light is reflecting, the incident ray, the reflected ray, and the normal line drawn to the point of incidence. That word is very important. It should be included. The normal line drawn at the point of incidence all lie in the same plane. All are there in the same plane. I will explain this again in the board. And the next one, the value of the angle of incidence is equal to the value of the angle of reflection. This is true for all the types of plane mirror reflection. It is true for all the plane mirror reflection. Okay, then we'll go back to the board. So I think you can see this diagram. In this diagram, we had incident ray, reflected ray, and the normal. Look at this line. This line is on the board. This line is also on the board. This line is also on the board. Now I can't draw the normal like this, no? Coming out. If I draw like that, it's wrong. So I have to draw on the same plane, on the same paper. If you are drawing in one paper, the incident ray is in the same paper, the reflected ray is in the same paper, the point of incidence is the same paper. That is the meaning of, that is the first law. The incident ray, reflected ray, the normal drawn at the point of incidence. You can't draw the normal here. You can't draw the normal here. You have to draw the normal at the point of incidence. That all these three are on the same plane. So that is the first theory. Three things: incident ray, reflected ray, angle of incident. Sorry, reflected incident ray, reflected ray, and the normal drawn to the point of incident. All are in the same plane. That is the first rule, first law. Please try to memorize that. The second law is very simple. Here itself you can see the incident angle and the reflected angle. When you look at the value, the incident angle value will always be equal to the reflected angle value. For example, if this is 30 degrees, if this side is 30 degrees, what is the angle of this side? 30 degrees. If this side is 60 degrees, this side also 60 degrees. Can you understand? So without writing the values, they are saying angle of incidence is equal to the angle of reflection. The short form for the second law is angle of incidence equal angle of reflection. This is the short method to write the second law. Now many students were saying, so how to memorize the law, how to memorize this second law, first law? I told, wait, in my classes, I will teach you the short methods. So I think now you all are 100% clear about this. Okay, students, so we'll move to the next one. Almost 1 hour is gone. Okay, so the time is flying. These days, the time is flying. Okay, and especially in my classes, the students, they say they can't feel the time going. You might have felt it today, no problem. So today we'll try to cover as much as possible. Okay, in our future classes, in our future seminar, we will do a lot of things. Okay, so once I send the PDF, normally the ones who want the PDF, okay, you will be able to get the PDF if you are there in our free groups. Okay, so if you are not there in the free group, you can put a WhatsApp message. We will add you to the free group. In the free group, and there are paid students group. In those groups, we will put the PDF. So once you get the PDF, now I have left a space here, no? Can you see? I have left a space here. When you are writing this, you have to draw the incident ray, the reflected ray, normal. You have to mark everything. Then with the drawing, you have the theory. Then it's very easy to study for your O levels. Not for O levels, your third term lesson. Okay, it will be easy for you to study for your third term exam. Okay, my students, I will be having a third term exam on December. I want you all to score well, and then I will promote you all to grade 10. Okay, we have a nice plan in our classes, in our theory classes. We have a very good plan. We are following that plan, and students also studying well. Okay, so the newcomers, they are asking about the class timing and all those things. Don't worry, I will tell everything. So please stay until 9 o'clock without any other distraction, without any other concentration. Today you will be learning one of the most hardest lesson in an easy way. So this is a very good opportunity, very good chance for you. So please concentrate properly. We can learn a lot from this short seminar session. Okay, then we'll move to the next one. Now you all know reflection. It's jumping, bouncing and coming. Sometimes there are regular reflection. sometimes irregular reflection. We call it diffuse reflection. Now, very simple. Very simple. Listen to this. Especially the boys will be able to understand. Now, the boys, you all are playing cricket, no? If the cricket pitch is smooth, what will happen to the ball when you're throwing? The ball will bounce and grow in a regular way. But let's say there are a lot of stones and mud and all those pieces in the middle of the pitch. Then what will happen when you put the ball? Will it bounce regularly? Sometimes it will bounce and go somewhere else. You all know why, no? Now all are watching IPL and all those things, no, getting ready to watch the IPL. One advice I am telling, don't waste your studying time to watch the IPL, okay? Anyways, if the pitch is not good, what will happen? The ball won't bounce properly. It will bounce in a irregular manner. Okay, we call it diffuse reflection. Okay, like that. When light rays also bounce in different methods, we call it diffuse reflection. Okay. Observe how parallel rays of light are reflected from a smooth surface and a rough surface using a plane mirror as a smooth reflecting surface and a crushed aluminium foil as a rough reflecting surface. Now for this experiment, not experiment, you have to take two things. One is a mirror, the other one is a crushed aluminium foil. Okay, now this is very simple, this activity. Okay, don't need in school and all, they will try to make it very big, very simple. Only the results I will tell you. When you put a laser light or a torch light to a plane mirror, what will happen? It will come and bounce in a proper way, regular reflection. But if you put in aluminium foil, crushed aluminium foil, it is a rough surface, no? Its surface is not polished. It is uneven. Now, have you all seen foil? You all have seen foil, no? Wait, I will show. Okay, I will quickly put the camera and show. Okay, you all have seen foil, right? So this is a plain foil. If I crush this foil and if I open it, now how is it? Very rough surface, no? Irregular. Okay, here and all, when I crush it, it's irregular. So if you put a light to this irregular surface, what will happen? Diffuse reflection will occur. Diffuse reflection. Normally they ask a question, if a foil is folded and then it is stretched, and if light is incident on it, what type of reflection will be available? Plane reflection, regular reflection, diffuse reflection, none of the above. Like that, they will give 4 answers. Then which one to select? Then you should be able to understand, okay, this is a rough surface, so there is no plane reflection, there is no regular reflection, it is totally diffuse reflection. You won't be able to say, it will bounce this side, it will go this side. You can't say, because it may go to the front, it may go to the back, it may bounce back, it may go to the left, it may go to the right. This is known as diffuse reflection. Okay. Then these are the 2 types of reflection. One is regular reflection. The other one is diffuse reflection. One is regular reflection, diffuse reflection. When you look at a regular reflection, can you see the pattern of reflecting? Now see this. This is number 1. That all of y'all, I hope all of y'all are listening carefully to me. Okay, first ray. Look at the first ray. It is coming, bouncing regularly, and the output of the first ray. This is the second ray. It is coming, and the output is here, second ray. Third ray. The output is here. It is the third ray. Here it is the fourth one. Okay, now I'm drawing from the mouse. That's why it's not that proper, but you can understand 1, 2, 3, 4. This is the fourth ray. Here, this is the fifth ray, and in the output, here the fifth ray. Here, this is the sixth ray, and in the output, reflected rays, this is the 6. So here also you have a 1, 2, 3, 4, 5, 6 regular pattern. The reflection also 1, 2, 3, 4, 5, 6. There is a regular pattern. So we called it this regular reflection. Are you 100% clear? The students don't know how to find out whether it is regular, irregular. Now I think if they give you some light rays, you will be able to understand which one is exactly regular, which one is diffuse. Okay, we'll look at the diffuse one. This one is the first ray. Okay, we'll put 1. Then that is bouncing and 1 is coming from this side. Okay. What about 2? 2 is coming like this, bouncing and going on the same surface. So 2 is somewhere here. This is 3. 3 is bouncing and coming from here. 4, it's starting from here. Incident ray. What about the reflected ray? Somewhere here. 4. What about 5? Incident ray is here. It's coming, knocking and coming out. The reflected ray is somewhere here. So when you look at the pattern, okay, when you look at the pattern, is there a proper pattern? Here 1, 2, 3, 4, 5, that is pattern. When coming, it is coming in the pattern. But after reflecting, is there a pattern? No, totally no. So this is the best way to find out whether it is a regular reflection or diffuse reflection. Some students were struggling. Now I think y'all are really happy. This is the easiest method to find regular reflection and diffuse reflection. Are you 100% clear about the method? Science is easy. I don't know who is making this science hard. Many people, when they open the mouth itself, so science is hard, I can't understand, like that, all are crying. I am telling you one thing, science is not hard. If someone explains you properly, science is the most easiest subject and science is the most interesting subject in the world. Okay, so then we'll move to the next one. Now I think your doubts are cleared. Then there are differences between regular reflection and diffuse reflection. Regular reflection always happens by a smooth surface. So the best example is mirror. Mirror is a smooth surface. Now, even if you take my whiteboard, that is a smooth surface. So that also can do regular reflection. Parallel light rays are reflected parallelly. Okay, how to explain that? I think you all know maths, no? In maths, can you see? All these are parallel rays. You all know parallel lines, right? When you look, compare this 1, 2, 3, 4, 5, 6 line, it's parallel. The output is also parallel. So parallel, input also parallel, output also parallel. That is regular reflection. Example, reflection of sunlight or whatever light on a plane mirror. When something reflects on a plane mirror, what is the method of reflection? Regular reflection. And reflection of a laser light by a plane mirror. That first picture itself we saw, no? That's an exact regular reflection. Diffuse reflection, this is done by rough or uneven surface. Uneven means not polished, not smooth. Some places are high, some places are low, some places are rough. Okay, it's done by that. And also parallel light rays are reflected to various directions. Okay, it is reflected to various other directions. Example, reflection of light rays by the pages of a book. Now, if you take a book, it's not like a mirror, no? Okay, it's not like a mirror. So therefore, when light rays fall on the book, it will scatter to many directions. That's why. But there is an advantage. There is an advantage. Because of that only, from any side you look at the book, you can read, no? You can see the pictures from any side. But in a laptop, can you see like that? Okay, now your laptop screen is there. If you're in front of the laptop screen, you can see. But if you go to another corner, can you see the laptop screen? You can see the screen, but the words won't be clear. Because from the laptop, from the computer, from the phone, parallel rays are coming to your eye. But from the books, a diffuse light is coming. Diffuse reflection is coming. Okay, how many of y'all are using the laptops? Raise the hand. Okay, yeah, many people, around more than 150. You all can try and see. Okay, you all can stand up and go to left side, right side. The clarity of the letters will change. But when you come and sit front, that is very clear. But when you go left and right, okay, it will not be that much clear. Because normally these LCD monitors, you all know LCD, right? LCD monitors, they are sending parallel rays, okay, not diffuse ray. Diffuse ray from any sides you will be able to see it. Reflection of sunlight by objects like the earth, the plants, the building, the rock, any other thing other than mirror or polished surface, all the other things have diffuse type of, diffuse type of reflection. Okay, I hope it's clear. Okay, so small things I will tell you. Practically try that. Then science is really interesting. You know, in my eye seminar about the eye, I was giving a very nice seminar. The ones who are not there for that seminar, the video is there in YouTube. You can watch that. In that, I am giving some small tricks. Those are known as optical illusions. Then the students were amazed by seeing those things. Can you remember that Mona Lisa picture? All those things. The students were amazed. Just raise the hand. How many of you all, for the first time you have come to my seminars? Now raise the hand. First time you have come to my seminars. Before this, you have not come to my seminar. Or any other classes you have not come. Okay, many new students are there. Okay, so those students, you can go to my YouTube channel. Okay, later I will tell you the name. It's known as Herbal Planet. You can go to that YouTube channel and you can check that video. That's very nice. I have two main videos for grade 9. One is related to circulatory system, about the heart, blood transfusion, all those. And the other one is related to the eye. And this is our third free seminar. So you all can watch those things in YouTube. Okay, then instance where regular reflection is useful. Okay, regular reflection is commonly found when using the mirror, because we are always seeing our face in the mirror, no? Okay, and also there is a plane mirror in the microscope. Have you all seen the light microscope? In that there is a plane mirror. I will show the picture later. Then to create vivid light patterns in various shows. Have you all seen in these music shows and all, the light will be there. That light is coming to different directions. Sometimes have you all seen, when there is a musical show, they will put a very powerful light to the sky. In the sky, you can see many patterns. Have you all seen that kind of thing? Yeah, no? Okay, so those kind of lights and all, they are using regular reflection. Okay, to get information of the motion of machine parts in the industrial plant, that means in the industries, to understand the motion of the machine, whether the machine is working correctly, rotating correctly, they are using some light method. Okay, those and all, only the people who are working in the factory, they know the method, but for now, we'll just try to learn that. Okay, don't need to learn deep about it. Then these are few instances where direct or regular reflection is being used. Can you see, when these lights are bouncing in a regular manner, there are nice patterns created. And also in the light microscope, you know, the light ray is coming like this and getting reflected like this. So because of that, you can use this without any light source, natural light source. From the natural light, you can use this microscope. I think in school you have used that, no? If you have not even seen a microscope, not even used a microscope, next time when you go to the school after Corona, tell your science teacher to take you to the science lab and show the microscope, and the light microscope, which is using a plane mirror. Then next is the instances where diffuse reflection is useful. Now to read your normal books in your day-to-day activities, for all this, now when you are looking at a person, from a person's face, light rays are coming, no? The bounced light rays are coming. Is it coming only in one direction? When you look at one person, can you see him only from one direction? No. If you go to the left also, you can see. If you go to the right also, you can see. If you go up also, you can see. If you come down also, you can see. That is because of diffuse reflection. So to read a book from all directions, you can look at a picture or a book from all directions, because from a book, the rays are getting diffuse reflection. So this picture you will be able to see now. See, from a tree, the light ray is falling from the sun and it is reflecting in different sides. So from anywhere you stand, you can see the tree because of the diffuse reflection. And also you can see a girl is reading a book. Okay, in the textbook they have given this book in this picture. So light ray is falling on the diagram, and that is going to the girl's eye. Because of that, she can read or see the pictures or the letters in the book. Okay, so I hope you understood what is regular reflection, and the other one is diffuse reflection. Another name for diffuse reflection is irregular reflection. So in the exam, if they give irregular reflection, don't get upset. I have not learned this. Irregular reflection is opposite of regular reflection. So that is the diffuse reflection. Okay, are you all clear about this? Are you all satisfied about the regular, irregular, the drawing? all
Very
those
clear,
things?
sir.
Yes, sir.
Very clear.
Okay, very good. Thank you. I'm really happy that you can understand, because okay, many parents were complaining about this unit. They can't understand this unit. No, if you learn properly, if you learn clearly, you can understand this lesson. Okay, then I will give you a 3 minutes break. Okay, I will give you a 3 minutes break. Now we are going to go to the next part, one of the most important part, how to draw a image ray diagram formed by a plane mirror. Okay, not only one ray, 2 rays. It's a very tough one. Okay, so everyone take a 3 minutes quick break, relax yourself, breathe, go out, look at the sky and come, breathe in, breathe out, and relax and come. We have the next part, so be ready. Even still, if your friends have not come, just quickly give them a message and tell them to come to our seminar. Even from the half, they will be able to understand as much as possible. So you can tell them, okay, your break starts now. Okay, then students, we will continue. I hope all of you all are ready. Images formed by a plane mirror. Are you all there? Please raise the hand and show me. Okay, good. Yes, you all are there, no? Good. Hurry. Images formed by a plane mirror. Okay, images are formed because of their reflection of light. Now, 100% we know. Emitted by the object, and from the reflected, that light emitted from the objects are reflected from the plane mirror. We know that 100%. For instance, the image of an electrical torch placed before a plane mirror can be seen through it. Okay, now this is very simple. Don't need to keep an electrical torch. You go in front of the mirror and see video. What can you see? You can see your image. Or else you keep another object in front of the mirror and see from the other side. You will be able to see that object. How can you see an object? Now, for example, you're also standing in front of the mirror. The object is also closer to you. How can you see the image of that object in the mirror? It looks like it is inside, no? It looks like it is inside the mirror. How did that object, now let's say you are holding an apple in the hand. You're holding, listen to this carefully. You're holding an apple in the hand and going in front of the mirror. Where is the apple? In your hand. How did that apple go into the mirror? Is it a real apple? No, it is the image of the apple. How did it go into the mirror? Because of the light rays which are going from the apple to the mirror, it is going and bouncing back. It is getting reflected. We can see as if the apple is inside the mirror. Like that we can see, but actually that is the image. Can you understand? Okay, so here and all, you don't need torchlight and all those things. Any object which is kept in front of the mirror will reflect and you can see the image of that object. So there are two things, one real thing, one false thing. So in this situation, this is the real thing. That is known as the object. Okay, it is known as the object. And this is the false thing. Okay, if you go behind the mirror, now you're holding an apple in front of the mirror. You tell someone, quickly run behind the mirror and see whether the apple is there. No, you can't find it. You have seen some small fellows, small kids. They grow in front of the mirror. They see another. Okay, they see another child. They think there's a child behind the mirror. They quickly run and go behind and see no child. Again, they come, see in the mirror. There is a child. They try to run behind, no child. You all might have seen, no? So you all might also have done that when you were small. Who is this fellow like me? From the mirror, like that. Actually, that is not the object. That is not you. That is your image. So like that, whenever something reflects, the object is there, that will reflect. Because of its reflection, we can see the image. So one side it is the object, the other side it is the image. I hope this is clear. Okay, don't need to do so much of experiments. Very simply, I will explain to you. This is the image and this is the object. Hare. So from this activity, what are the observations you are seeing? The light reaches to the eye from the object which get reflected from the mirror. So from the mirror, it is getting reflected. Because of that only, we can see the object and also we can see the image through the mirror. So how to draw a diagram for this? How to draw a diagram for this? So that is one of the hardest part in your syllabus. So we see as the light reaches to the eye from the point behind the mirror. We can see like the apple is behind the mirror. That apple is not the real apple. That is the image of the apple. In this situation, we see that the light ray is coming from this side, but actually that is the image of the torch. The real torch is in this side. The image is only here. So can you understand the difference? Okay, so this one, how to draw the diagram. So they are telling you need a laser light, 2 laser light, a white paper, a pen, a plane mirror, all those things. Okay, in school you will try to do this, but finally you won't understand because all the light rays are there. So for you to understand this, one by one you have to learn. Okay, so now we are going to the hardest part of this lesson. Hardest part. So I want you all to concentrate very well. Look at the board. Don't look here and there. From the first, you have to observe the board. Then only you will be able to understand this question or this method of drawing a ray diagram properly. So look at this carefully. Okay, so listen to this carefully. In your textbook, okay, in your textbook, they will give you, okay, they will give you one method. I will show you another method. Both are correct. Okay, both are correct. Okay, they will give like this. This is also correct. Okay, this is also correct. But shall I show you in a different method or same method? I will show you in an easy method. Okay, I will show you in a easy method. Yeah, we'll go to the camera and then I will start it. Hurry. In the school or in the textbook, they will draw the mirror like this. I will make it easy for you. I will draw the mirror like this. This is the mirror. This is the mirror. Now you are keeping a small ball in here. Okay, let's say we are keeping a small box like this. What is that? It is the object or the image? It is the object. It is the object. Then from this real object, many light rays are coming because this object, it is sending diffuse reflection. Some light rays go like this, some like this, some like this, some like this. Millions of light rays are going. If we try to draw the light rays for all, we can't draw. So we are selecting only two. So I will select two from the midpoint. You can also select anything. Okay. From here, I am selecting two lines. Okay. I am selecting two lines. Wait, I will draw that two lines. This is one line and this is the other line. Okay, this is the other line. Those are the, I am drawing two incident rays. Okay, two incident ray. This is incident ray 1. This is incident ray 2. Incident ray 1, incident ray 2. First we drew only one. Now we are doing two rays. Okay. Then now what should you do? Now this is one incident point, one bouncing point. Now think like two balls are coming. Both will bounce. This will bounce here. This will bounce here. So this is point of incidence for this incident ray. This is point of incident for this incident ray. Okay, so don't confuse. I am teaching one by one. So listen carefully. So we can draw the normal. This is one normal. This is the other normal. This is one normal. This is the other normal. Why two normals here? Because two rays are there. Two incoming rays. Therefore, normal ray for the first ray, first incident ray, normal line for the second one. So I have put N1, N2. No confusion at all. Then this one, incident angle. Now between the normal and the incident ray, we call incident angle. This is incident angle of first diagram or first ray. Then what is this? Now I'll make this in normal little bit more bigger. What is this angle? Incident angle of the second ray. Are you all clear? Two balls, two bouncing, two normals. If there are two normals, two rays, there are two outputs. Okay, now you can mark this exact angle. You know the laws of reflection. What is the second law? What is the second law? Incident ray equals reflected ray. Incident angle equals reflected angle. Okay, incident angle equals reflected angle. So if this is the incident angle of this line, this is the reflected angle of this line. Same, it won't change. Now you draw the output line. This is the output line. That is the reflected ray of the first diagram. This is the incident ray of the first line, reflected ray of the first line. I put number 1. That is one story. Now we'll look at this second line. Second line is coming, it's bouncing. Now we are going to draw the output. That is the reflected ray. So same angle, here also same theory. Incident angle of this is equal to the reflected angle of this. So same length. If you have a compass, you can check the angle and you can draw. Now I am just taking rough like this, like this. So this is the second one's reflected ray. Okay, that is second ray. Can you see? First line is coming, bouncing like this. Second line is coming and bouncing like this. So this is how the light is going. So this is the mirror. Okay. But the object is here. If a person is keeping his eye and seeing that object through the mirror, where will he see the object? Actually, he will see the object somewhere here. That is not the object, that is the image. So how did the image come here? To get the location of the image, you have to do a very, very simple thing. You have to just pull these lines. Now this line is there, no? Reflected ray 1, you just extend it. Reflected ray 2, just extend it. So they will meet at a point. Reflected ray 1 and reflected ray 2's back part. It will meet at one point. Can you see? That point is the place where you can see the image of that object. So if I am standing, this is the mirror. I am looking at the mirror. Where can I see my image? On the behind the mirror. That's why this is the object. This is the image. Can you see how to get it? This is the hardest part in your grade 9, I think full syllabus. This is the most hardest graph. So I have explained in such a way. Now if someone sees this diagram, they can't understand anything. That's why I told you one by one, you have to listen. At home, maybe after class, 9 o'clock, I will finish the class. Take 15 minutes, if possible, try to draw this again clearly. Incident ray 1, incident ray 2. Are you all okay with that? Okay, now please be supportive. Are you all okay with that? Incident
Yes,
ray
sir.
1,
Yes, sir.
incident ray 2. Okay. Okay.
Yes, sir.
Please explain how the reflection is coming.
Oh,
Hurry, okay, okay. This is the incident ray, 2 incident ray. I can draw 3, I can draw 4. Then book will become totally, the board will become filled with lines. So here 2 is enough. This is the object. Okay, in your school, they will do with 2 laser light. This is 1 laser light. This is another laser light. Like that also you can think. 1 laser light is coming, knocking, bouncing and going. The other laser light is coming, knocking, bouncing and going. If a person is seeing the laser light from here, he will think, it is coming from somewhere here. But actually, is it coming from here? No, 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 no. It is coming and bouncing. But when looking, he will think it is coming from here. That's why the small children, when they look in the mirror, they think behind the mirror there is a child. And they run and go to see that child. But the child is not there. So if I keep an object here, now if I keep, what should I say? Now this is the mirror. If I keep the marker's head here, marker's tip, and look from the mirror, what can I see? I can see another marker's lid there. So if I keep the marker lid here and go behind the mirror, can I catch it? Can I catch this? I can't catch this because this is just an image, not a real thing. So this is how you get the location. Your first theory, the first theory you learned in school, the same thing, they are turning like this. Now if I remove the board and turn like this, how will it be? Like that only they are giving. But this is easy to understand. Okay, this is, I think, easy to understand. This is the object. The light rays are coming and bouncing. Light rays are coming and bouncing and going. And the point where the image is formed is found by extending these 2 lines. It will go and stop at one point. Both will join at one point. That is the image point. Then from this diagram, you can find another thing. This is the distance between the object and the mirror. It is known as the image distance. Sorry. Not image. Object distance. If you stand in front of the mirror, the distance between you and the mirror is equal to the distance between. Now you're standing in front of the mirror. Now let's say mirror is here. If I am standing here, mirror is here. This is the distance between me and the mirror. But my image will be there behind the mirror, no? That image distance and the mirror, that is also same. So that is known as the image distance. I put a IMG. IMG means image. distance. Both are same. Can you understand? So I think from this diagram, this is the diagram. If you can understand this, I will tell you, you will be able to understand real science, no problem. Okay, so the students who can't understand in one shot, again and again, try to draw this alone. Don't copy. What will happen if you copy from the book? Just you will draw the lines. You take a full empty paper, one by one, start from the first line. Line 1, incident ray 1, reflected ray 1. Then line 2, normal 2, incident angle 2, reflected angle 2, reflected ray 2. Like that, if you draw, you will get a very nice diagram. I hope it is clear. Yes. So you all can draw this. Now we don't have time for me to allow you to draw. So we will go to the next one because we have to go to the uses. That's also very, very interesting. So then I will go to the next diagram, and in your book, this diagram has been given. The same diagram. Now what did I do? I put the mirror, standing mirror. Here they are putting a sleeping mirror, and they are keeping an object here. Can you see this? They are keeping object here. Incident ray 1, reflected ray 1. Incident ray 2, reflected ray 2. And the back portion of the both reflected rays are joining. That is the image location. Now this picture will be easy. If you directly try to study this picture, you won't understand anything. What they have not mentioned? No, they have not mentioned incident ray 1, incident ray 2, reflected ray 1, reflected ray 2. Nothing mentioned. How are you going to study? Someone has to explain this. So I think that my explanation cleared all your doubts, and now you know how to do. Only thing is you have to try it again and see to confirm. Okay, so today you do this and see whether you can draw this diagram alone. If you can draw, be happy. You are a successful. This seminar is successful for you. If you can't draw, if possible, I will try to put this video in YouTube. In another 1 week, it will be there in YouTube. In YouTube, you watch again, try to draw. If you can't draw, again watch, again draw, again watch, again draw, until you get it correctly, 100% correctly. You draw. That trying, the times you are trying more and more, it will give you more and more knowledge. Okay, then we'll move to the next one. Okay, then many people, they were having a problem with the online classes because they are going to many online classes. In all the online classes, they are just reading most of the classes. Okay, some teachers are there. I'm very sad to say they don't know to make the PowerPoint presentation. So they are just typing everything. Students are boring. Many are sleeping in the online classes. But I can happily say in my classes, mostly they don't sleep. Okay, I am really happy because I have got the comments from grade 9, grade 10, grade 11. This is the only class they don't sleep because science is already, some lessons are boring. If I just read, today we are going to learn about the waves, reflection of the wave. Reflection means, if I read like that, after that, at the end of the class, nicely you will be sleeping. Okay, so the benefits of our online classes, okay, of our science classes, okay, the explanation is 100%. You don't have to worry. You will get the best explanation. You can study from anywhere without missing any lesson because it's online. No, if I tell you every Sunday morning 12:30 I am having my science classes, you can come from your home, from your auntie's home, from your uncle's home while you are in a trip, no problem. Even if you are in the hospital, nowadays some students are under quarantine. They are in the hospital, in the quarantine center. From there, they are listening to class. Even if you go to quarantine center, you don't need to miss the classes because everything is online. The other one is no need to miss classes due to illness, due to journey, maybe school extracurricular activities, trips, or maybe someone passed away. If you miss the class, you can get a recording. If there is a valid reason from the institute, they will send a recording also. So if you have a valid reason, they will send that also. So don't need to worry. And also the most important thing, you can study under the guidance and supervision of your parents. Now, many girls, the parents are scared to send to classes. Why? Because they have to send in the bus or they have to send somewhere out. They don't know about the people. So now you don't have any problem. Your child can be in the home and you can be studying under the supervision of the parents. And also no travel cost, no wastage of time when traveling. You know, for my classes, my Dehiwala classes, some students were there, they came from Tihari. Okay, one student came from Tihari. In the morning, he has to travel 1.5 hours to come to my class. Class is just 2 hours. After finishing the class, another 1.5 hours he has to travel in the bus. But now online, no. Now they don't need to travel. Okay, so like that, many students, they waste a lot of time in traveling for physical classes. But now, because this is online class, my classes until your O level, your my 2023 batch, until the O level, I will have online classes. So you or your parents don't need to worry. Inshallah, if I am there, I will be continuing the online. So you can save a lot of time through this online. So safe, secure, and inshallah, God willing, we will continue until the O level. So you don't have to worry. Okay, I will be sending the tutes when our institute starts, when this lockdown and all finish. Printed tutes will be sent to your home. A lot of things are there. We have many competitions also. In future, we will be introducing young scientists competition. Okay, so that is one category is grade 7, 8. Sorry, grade 6 and 7. The other category grade 7, 8 and 9. Okay, there is a competition. Your YouTube videos will be published, and the ones who are getting the most likes and the best scientific experiment will be getting a very good gift also. Okay, so a lot of interesting things are there. Online exams are there. Last time we had online exam. Many students scored 100 marks. We couldn't send their gifts because of the lockdown problem. Our institute didn't still open. Once we open, we will send their gift, and we have a lot of things to do. Okay, only thing is the students, they were asking about our normal online classes. This is our normal online classes timing. Every Sunday from 12:30 to 2:30, we have science lesson. Okay, the fees is a very, very minimal amount. For the students who are out of Colombo, it's just 800 rupees. For the Colombo students, it's 1,000, because Colombo students, we normally recommend you to come to the physical classes. Okay, so we have reduced the institute fees and brought it to 1,000. I have fought with the institute. Maximum I told them to reduce and bring it to 1,000. Outstation students, they are however online no. Until O level, they will be online. So no problem. They can pay 800. Okay, so admission is just 500. So if you want to join the classes, you can contact us. This is a all island online class. Okay, don't need to be from Colombo, no need to be from Kandy, don't need to be from Kurnagalore. You can, even if you're in Jaffna, I have students from Jaffna, from Gaul, from Eastern, all over. We have already started. We are moving to third term lessons. Okay, so anyone who wants to join can join and continue their grade 10, because okay, then I think from the institute, they told us they are giving a small special offer for the new students who are joining in September. Already 2 classes finished now in September, theory classes. So we have only 2 classes. So you don't need to pay the fees for that. You can only pay the admission fees. Okay, just 500 rupees for this month. Only the admission fees. We are not taking the monthly fees. Only pay the admission and join the 2 classes for September. From October, November, December, you can pay the monthly fees and join. So this is a special offer given by the institute. Okay, so the new students, many said that this is the first time they have come to my classes. So if you want to continue every week, every Sunday, we have classes. Free classes once in 2 months, because I also can't keep every day, no, because I have to keep free class for grade 10, grade 11, grade 7, grade 9, grade 6, grade 8. So when coming in rotation, once in 2 months, we will have free classes. But if you want to learn the full lessons, you can come to our theory classes if you want. Okay, now I am not forcing anyone or anything. If you like, if you are not going to any other classes in school also, they are not doing properly. If you can't understand science, don't need to worry. You can join us and you can gain a lot of knowledge and you can improve. You can see the improvement within few months. Okay, so this is my WhatsApp number, the institute number. You can send a WhatsApp message. The admission forms will be sent to you. Okay, so the special offer is also there for the new students. You can get that special offer. Don't worry. All the tutes, all those things will be provided. You can come in contact with us. Okay, then. Okay, so don't worry. The diagram photo, some students are saying, sir, we couldn't write the diagram, draw the diagram. In the free group, the diagram photo will be sent. Okay, don't need to worry. The diagram photo will be sent in the free group. You can draw that later after the class. Okay, then Now we'll do a nice one. Now I think, okay, now we'll go to the theory part. Okay, don't worry, we'll go to the theory part. We have some more to complete. Don't leave. Okay, until 9 we will be continuing, so please wait until that. Okay, now this is a very simple thing. Okay, you should have this activity. You don't need to do the same activity. Okay, you can just go in front of the mirror and look at your image. What can you see? Are you upside down? No, you can see your normal image. That is known as upright. Then the next one is lateral inversion. Okay, this is a nice thing. I will explain about lateral inversion. In plane mirror, in normal mirror, lateral inversion occurs. Okay, lateral inversion, new name. Repeat it 3 times. Lateral inversion, lateral inversion, lateral inversion. Then only, I told you, no, first it has to go to the mouth. Then only it will go to your mind. First mouth, then mind. So repeat again and again. Lateral inversion. Lateral inversion occurs. This is a very simple thing. I will explain. Okay. Equality of the size of the object and the image. Now, when you're in front of the normal mirror, is your size increasing? Are you height? Are you short? No, same height. Equal height. And what about the image? Can this image be taken to a screen? No. It is a virtual image. We call this image virtual. If you go behind the mirror, is the image there? No. It's known as virtual image. So what is the definition for this virtual lateral inversion? I will tell you. Now in this experiment, they are telling you to make a image like a bee and show to the mirror. How can you read it? Okay, I will show that. Okay, we'll discuss that. Each and every word I will explain. Don't worry. Now first you have to memorize the characteristics of the image formed by the object which is kept in front of the plane mirror. If you keep any object in front of the mirror, you will always get a virtual image. Memorize this. Not a real image. It is an image. Image also there are 2 types. One is virtual, one is real. Have you all seen a projector? How many of you all have seen a projector? All of you all have seen, no? From the projector, the light comes. That is an image. That is a real image. Because if you keep your hand in front of the projector, that image will fall on your hand, no? If you keep a screen, that image will fall on the screen. So that type of image is known as real image. But if you keep the hand behind the mirror, will the image of that mirror fall on your hand? No. It won't fall. Those kind of things. The images which do not fall on a screen or a sheet or your hand, those kind of images are known as virtual image. Okay, for example, I can tell you like this. In dreams, you're seeing things, no? In the real life, you have seen an apple. You can catch that apple. That is a real apple. But in the dreams also, you're seeing the apple. Can you catch that apple in the dreams? Maybe in the dreams you can catch, but can you feel it and can you take it to the real life? Can't, no? Virtual image is also like a dream. You can see, but you can't touch or feel or take it. Okay, so virtual image is like a dream image. The next one, the next characteristics is upright. What is the opposite of upright? Upside down. Okay, normally we say, no, what is this? Everything is upside down. Upside down means opposite side. But in the image, when you go in front of the mirror and see, your head is on top. In the image also, head is on top. Head is not in the bottom and leg is up. Not like that, no. There are some mirrors. There are some cameras. Have you seen in the phone? If you put one option, you can see the other person upside down. Left to right. Right to left. Like that you can see. But in the real mirror, that doesn't happen, no. In the real mirror, that doesn't happen. It is known as upright. The next one is equal to the size of the object. Always when you look at your image in a mirror, proper mirror, the same height. The fellow who is in the mirror is taller than me, shorter than me, nothing like that, no? Same height. So these things, why I'm telling with example, then only easy for you to memorize. Virtual image, upright image, same size, equal size, same as the object. The other one is object distance is equal to image distance. I told you first itself in that diagram, I told you object distance is equal to the image distance. Object distance is from you to the mirror. Then image distance is from the mirror to the image. Okay, now all this you have to try in front of the mirror. You go in front of the mirror, you see the virtual image. Okay, whether it's upright, yes, you can see. Whether equal size, you can see. Then distance of the object distance and mirror distance, you move closer to the mirror. Then that image also will come closer to the mirror. You go behind the, you go a little bit back, few steps back. What will happen? That image is also going back. So the distance is, according to you are changing the distance, the image is also changing the distance. Can you understand? And the final one, lateral inversion. This only I want to explain more clearly. What is lateral inversion? Lateral inversion, changing the right hand side and the left hand side of the image is known as lateral inversion. So if this is the object, if you draw the letter D, when you look at the letter D from the mirror, you can see something like this. It's not upside down. Left and right has changed. That is known as lateral inversion. So you quickly go in front of the mirror and raise your right hand. Raise your right hand. What hand is the image raising? Quickly tell me the answer. You do and see. Everyone quickly run.
Left hand.
Yes. When you raise your right hand, the image will raise his left hand. Now think, two people are there. You tell your mother, Mama, come in front of me. You and your mama face straight. And now you raise the right hand. Tell your mama to raise the right hand. She will raise the right hand. But if you go in front of the mirror and you raise the right hand, the image will raise its left hand. It will be like the image's left hand. Can you understand? That is only known as lateral inversion. Left and right is changed. Can someone tell me a situation where this lateral inversion is very, very important? Normally in one place, they already invert it and right in one place. Does anyone know? We'll see anyone knows that place.
Ambulance.
Very good. Very good. Okay. In the ambulance, in the front side of the ambulance, already the word ambulance is laterally inverted and written so that if you're driving a car, from behind ambulance is coming, you don't turn the head and look at the ambulance. No, from the side mirror you're seeing. Side mirror is a mirror. It will show you lateral inversion. So already they have lateral inverted. So you can properly read ambulance. Okay, next time, whenever you see ambulance, look at the front side, how the word ambulance is written. It's totally written left to right. Okay, next time you have to do that. Okay, science is life. Okay, I told you always in my, this one I put, science is the art of life. Okay, day-to-day activities, everything is science. You're breathing, that is science. Your heart is beating, it is science. You're looking, it is science. You're using a computer, computer is science. Physics, electronics, your phone, your camera, your pencil, your marker, everything in the world is related to science. The sound which you're hearing, it is science. So science, I am telling you, Buddha, it is the most important and interesting lesson in the world. But unluckily, in Sri Lanka, most of the students, they are hating science. I know there are two reasons. I don't like to say the reason, but one major reason is the teachers. They are not teaching the science lesson properly or interestingly. They are just reading and they are not doing the experiment. They are not showing practical things. Because of that, students are getting angry with science and they are hating science. But after coming to my seminars and my lectures, most of the students, they say, sir, now I love science. I like to do science. I want to become doctor. I want to become engineer. I want to become scientist. Like that, many people, they tell me, I am really happy. Okay, I am there to guide you. In future also, if you want to do A-level, bio, science, maths, I can guide you. I can show you to, I can tell you the good teachers in Colombo. You can come and learn from them, or online you can learn from them. So I can guide you because I know that field very well. I can guide you. So just raise the hand. How many of you all like to become doctors? Oh my God, there are more than 200 doctors in this class. Very good. I pray that everyone becomes doctors. It's not an easy thing. Okay, you have to work hard. Okay, you have to work hard, you have to learn a lot. It's the most interesting part. It is the most interesting lesson. It is the most interesting subject. I pray that everyone becomes doctors, but you have to do hard work. From now itself, you have to start. Okay, not only doctors, even if you want to become engineer, if you want to become accountant, if you want to become a good civil engineer or electrical engineer or a scientist, from now you have to start any field. Nowadays, it's starting from grade 9. Okay, then the next one is virtual image and real image. If the image can be taken on a screen, it is known as real image. If it cannot be taken on a screen, it is known as virtual image. Okay, I will show you an example for real image. Then you will know the difference. Now see, this is a lens. Have you all done this experiment? Maybe for a candle or sunlight. How many of you all have done this for the sunlight? If you take a hand lens and keep under the sunlight, there will be a one point which is very, very hot. If you keep a matchstick in that, what will happen? It will start burning, no? Don't do this to your friend's hand, because one of my friend did it and that part of my friend's hand got burnt also. Still that mark is there. Okay, 10 years back they did, still that mark is there. So this type of image, now here you can see, this is the object. And can you see a small dot image on the wall? That is the image. These are real image. The virtual image, should I show the example? No, you go in front of the mirror and see yourself. That is the virtual image. Understood? No, practically you can study this. Then what are the uses of this mirror? Okay, we are moving to the last part. So we are going to finish the session. What are the uses of the plane mirror? Every day we are used in salons, beauty parlors, to see our face, no? When cutting the hair, you look at your face, no? Always in a salon, in front of you, they have a mirror. Why do they keep the mirror? Then only you can see your face. Every day morning, when brushing the teeth also, you are looking at your face and only brushing. Most of the people, it's like that. Then in the shops, to increase, to show the number of items. For example, here, tell me how many bottles are there? In this picture, how many real bottles are there? Oh, 1 minute. I can see all the okay. So how many objects are there? How many real object is there here in this situation?
One.
Okay, only one is there. But how many images is being formed? By keeping the mirror, they are taking many images. Sometimes in the shop, it's like that. They have only little things, but by keeping lot of mirrors, they are trying to take maximum images. Okay, so to show that they have a lot of things, they are trying to do that. Okay, and also to produce multiple images. Have you all seen, if you keep two mirrors facing each other, and if you keep something in the middle, you can get thousands of that image. Okay, infinity amount of that image. And the other one, to reflect light for laboratory activities. Okay, when you are using laboratory activities in your school laboratory, science laboratory, or the scientists in big laboratories in the world, what are they doing? They are using, especially in the microscope, they are using these plane mirrors. You all know, no, in the microscope, especially they are using light microscope, they are using a plane mirror. And also to observe the shape and the backside of the customers when selecting the dresses, and also when cutting the hair. The barber will show you, no, from behind he will hold a mirror and show you the back part. From the front mirror, you can see this, you can say, okay, or else little bit short more. Or the girls, to see their ponytail, how they are tying their hair, they can see by using the mirrors. Okay, those are day-to-day activities. And also one special equipment, Kaleidoscope. I think many of you all have seen the images from the Kaleidoscope. Have you all made, how many of you all have made the Kaleidoscopes when you were small? You only need 3 pieces of mirrors. If you have the 3 pieces of mirror, what can you do? You can make a kaleidoscope and you can put 1 or 2 pebbles into it. And when you see from the mirror, you will see like thousands and thousands. Okay, so this is a simple kaleidoscope. Inside the kaleidoscope, you can see so much of designs when you are turning. Okay, like this. I think you all can see the screen, the designs. Okay, the next one for making periscope. Okay, kaleidoscope is one example. The other one is periscope. I think you all have done this. Where can you find the periscope? Normally there is a equipment or a machine in that always this periscope. Yes, very good. In the submarines. Okay, normally in the submarines, the periscope is a must. So the person who is in the bottom, they will be able to see what is on top by using this by using this periscope. Okay, how is that? The image from this tree will go, the light ray will go, here is a mirror, it will get reflected and go below. Here another mirror, reflected, and it will come to the eye. So this person is somewhere below in this level, but he can see something which is on top. You can see that tree. Can you understand? So the people who are inside the submarine, if they want to see out of the sea, if they want to see above the sea level, they will put this and they will observe from bottom. So I think all of you all know the submarine, no? It is normally below the water. While it's below the water, on top, they don't know where is the land, whether the ship is coming, whether the enemy is coming. So what are they doing? They are only sending this periscope up, and from that they are observing the outside surrounding. So that also has a plane mirror. Okay, so like that, you have many types of mirrors. Do you know the names of the 2 curved mirrors? There are 2 curved mirrors. Do you know the names?
Convex.
Yes. Concave mirror and convex mirror. Concave mirror and convex mirror. So all this you will study in grade 11. Don't worry, I just gave you the name. This is a concave mirror. You might have seen it's there near the dentist or in the beauty parlors, it is there. And convex mirror, even in the road. I think how many of you all have gone to the Daha Atavangua? In Sri Lanka, there is a place where there are 18 curves when going to Mahiyangana side and all. In that Daha Atavangua, they have put these mirrors. Have you all seen this mirror? Next time when you go to the Daha Atavangua, you see this, so that the people can see a large area whether another car is coming or not. They can see from this convex mirror. Okay, so just I wanted to ask, did you, now this is today's lesson, did you understand today's lesson, and are you all clear about
Yes,
what we learned today?
Yes, sir.
Very clear, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay, I'm really happy to hear that. Okay, because some students, they go to science class, after that they say, I can't understand anything, mainly in schools. Okay, after school lesson, they are complaining. Mothers are calling me and saying, sir, they are going to school, the teacher is teaching for 2 hours. After teaching, the student is coming and saying, Mama, didn't understand anything in school. Okay, so in my classes, that doesn't happen. I'm really happy. If you have any further doubts, you can send a WhatsApp message and ask. I'm ready to explain it to you. Okay, but don't say, sir, I didn't understand anything, explain from first, then I can't explain. If you can't understand one specific point, you tell me, I can explain it to you, no problem. Okay, so I hope you understood. Okay, today's session is one of the most important one. It is very hard. In some schools, they are skipping this. They are not showing how to draw the ray diagram, because the teacher, when they explain, the students are saying can't understand. So teacher will get fed up. So some teachers are not even explaining. Okay, but but I took the challenge. I said, no, if this is hard, I will find an easy method to teach my students. So I said I will put the camera and put the whiteboard and try maximum to explain today. So I think maximum majority of the students, they understood today's session and they are really happy. Even now they have sent some messages. Thank you, sir. This was the hardest lesson. Now it is easy for us. Okay, so in our theory classes, we have our future plans. Okay, so this September we have some more to complete. This lesson is totally not finished. No, we have a reflection of sound waves, a refraction of light rays. With that, unit 14 will finish, and in October we will complete unit 15, unit 16, and in November 3 units we are completing because all are small units. And in December, finally, we are having our third term exam. And in December itself, my classes, we are starting grade 10. We won't wait till January because, okay, if you start from December itself only, next December, before the next December, you will be able to complete your grade 10 lesson. Okay, so maybe there are students, today only they understood my classes, they have come to my classes, they are thinking in vain, no, I should have come early. So now no use of crying. Only thing is you can join and finish the third term lessons completely, and after that start your grade 10 fresh. Very, very, very important. Grade 10 is very important because it is your O level, starting point of your O level. If your grade, now you know what happened in grade 9 and grade 8 due to corona, you all don't know grade 8. Now due to the third and fourth wave, grade 9 is also just going without school. Even if there is school, teachers are not teaching properly, like that, many complaints. So don't worry, start grade 10 freshly. Don't make the same mistakes which you made in grade 8 and grade 9. Okay, maybe grade 10 classes also, if the country doesn't open, even school, it will be online. Again, they will do in the same method. So don't worry, our online method is the best in Sri Lanka. So you can come without any problem. Now you all are in grade 9. This is the foundation of your O level. But next month, not next month, in 3 months, you are going to go to grade 10. Okay, now when I say this, you all are thinking, yo, so are we grade 10? We are like still small children. No. You all will think like this only. Your eyes will go like this, up and down. But whatever you do, now you are going to jump to grade 10. And after grade 10, see how quickly this year went. Corona came, January, February, March, April, May, June, July. And now already September is going to finish. So like that, grade 10 also will fly. Grade 11 also will fly. But you have to face your O level. Okay, so this is the time where you get ready, prepare everything for your O levels. And okay, because grade 9 is like the foundation and the grade 10 is the real basic first stage of your O level. If you miss grade 10, very, very hard. Okay, because I know all the grade 11 students, most of the people, they are again coming to grade 10 classes. Why? Because in school they have not done, they have not studied the grade 10 properly, they can't understand grade 11. So again and again, I am telling you, don't miss your grade 10. Okay, so you can continue the third term lessons properly and then jump to grade 10 and start fresh. From grade 10, I have a special plan. We will go according to the plan. When you come to grade 10, you will be able to understand advanced lessons. All are real bio, real chemistry, real physics. In the book itself, they have separated. Okay, so it's the real science. So until you come to that real science, you should be able to complete your basic foundation. So I think this is enough to motivate you to study well, to concentrate well, to concentrate more in classes, and to make science the most interesting and the important lesson in your O level. Okay, so I wish you, okay, that all of you all target 9 A's for your O level, because it is the first and best gift which you are going to give your parents and your teachers. Okay, this, if you get 9 A's, your teachers and your parents will be really, really, really happy. There are many people waiting in your family, in your uncle, aunties, your neighbors. If you get low results, to criticize you, there are many people. So don't make the criticizers to criticize you. Get the best results. Try now itself, keep a target. I want to get 9 A's for my O levels. That should be your target. Put a plan. In my last seminars, I have given counseling. I have told you how to put a plan, how to arrange your table, how to eat in the morning. Everything I have explained. The new students, you can watch my YouTube video. My YouTube channel name is Herbal Planet. Okay, you can type this in YouTube. Herbal Planet, HERBAL, Herbal Planet. So your grade 9 videos will be there. Even some grade 10 videos are there. If you like, you can watch that also. You can study now itself. You can start studying the grade 10 lessons. Okay, so yeah, so I think that is enough. So I hope you understood today's session. Again, this is our normal theory timing. We don't have any other timing because I'm a doctor. I'm a medical final year student. Okay, so I don't have time to, I'm not like other tuition teachers, everyday tuition. Okay, once a week, grade 9 classes. Okay, every Saturday, grade 6, grade 7, grade 8. Every Sunday, grade 9, grade 10, grade 11. That is my class schedule. Okay, so Sunday, 12:30 to 2:30 p.m. we have the grade 9. Okay, for the Colombo students, it's just 1,000 rupees. And for the outstation monthly, it's just 800 rupees. So this month, there is a special offer. The newcomers, you don't need to pay the full fees. You can only pay the admission and come to our remaining September classes. The remaining part of reflection, refraction will be covered, because in seminar, we can cover only one important part, because if I teach you everything, you will get confused. So today's session, I think it's totally embedded in your mind. And now next week, we will learn the other part. Okay, then students, we have online classes for grade 6, 7, 8, 9, 10, 11. If you have younger brothers, you can inform them. If you have elder brothers and sisters, you can inform them. Anyone can learn real science by joining our Science Academy, Institute of Science. So if you want to join, okay, you all know the benefits I have told you. I don't want to repeat again. If you want to join, you can send a WhatsApp message to this phone number. So I hope everything is crystal clear, what you learned about our classes, all those things. Encourage your friends more and more to come to our classes and benefit maximum and understand the reality of science. Okay, then students, thank you for joining the session. I would like to end the session, and I would like to see you in the theory classes and also in our future free seminars in another 2 months, maybe November. We will have again free seminars. Stay in the free seminar group. Don't leave, because in that group every month, all the seminars, related seminars, free books, free notes, free PDFs, everything will be uploaded. So free group, anyone can stay, no problem. Don't need to pay or anything. But if you're joining our paid classes, you can get the admission and join our paid groups. Okay, so the institute will add you once the payments are done. So you can deal it with this institute number. Okay, then students, I hope that you have understood today's session, and I hope everything is clear and you all are happy with the session. Are you all happy with the session?
Yes, sir. Jazakallah, sir.
Okay, who is that? Nice singer. Good. Okay, then thank you for joining the session. We will end the session now. Hope to see you all in our future classes.